Let's find the volume of a solid of revolution obtained by rotating a region bounded by parabola y equals x squared, the line y equals x, as this region is rotated about the vertical line x equal to minus 3. So recall what this region is. This is a region that's in the first quadrant. Here is the part of the parabola x squared. Here is the line y equals x. They intersect at 1, 1 and 0, 0. So we mark these 2 points. Here's our region. All right, this is the origin. And the parabola right now is expressed y equals x squared. If we want to solve it for x in terms of y, x equals plus or minus square root of y. Since this is in the first quadrant where x is positive, x equals to the positive square root of y. And of course, this is the line y equals x. To solve for x, it's very easy. We just turn these around. So x equals to y. Now, we can sketch the region once again and also bring in the axis of rotation. So here's the axis of rotation. This is the line x equals minus 3, and we want to sketch this region 180 degrees after it's been rotated about this line. So this point over here is 3 units away from the axis of rotation. It's going to end up here at -6, and then this point is 4 units away, so it'll end up somewhere over here. And then we can sketch kind of a rough sketch of this region. So here it is. Now pick a y anywhere between 0 and 1. So here's a typical y. Now the trick to this is always refer to the original region. Don't refer to the region that's reflected about the axis of rotation. Here is the original region. We keep track of this horizontal piece of the area. It's going to end up over here, and as you can see, a full 360 degree rotation gives us cross section, which is this washer. So here is the washer. We're interested in finding the area, which is going to be, if we take this area multiplied by a tiny length of a tiny interval, that gives us a cross section of the volume. So let's look at, remember how to find the area of a washer. If we have 2 circles, one the big circle, and then we cut out a center, a small circle out of it. The small circle has radius small r, the big circle has radius big R. The area in between is pi times the big radius squared minus pi times the small radius squared, which is simplified pi times big R squared minus little r squared. Now we go back to our region and recall that this part here is x equal to the square root of y, and this part is x equal to y. So the center of our washer is on the axis of rotation. The big radius is going to be all the way to the parabola. So it's 3 units to the y-axis, and then additionally there's the x-coordinate on the parabola, which is equal to the square root of y. So the big radius is 3 plus the square root of y. The small radius, 3 units to the y-axis, and then additionally to the line, the x-coordinate on the line, which is equal to y. So the small radius is 3 plus y, and that's the key. Now we can set up our integral. We're taking these washers, they're everywhere. For y between 0 and 1, we have the pi, then the big radius 3 plus the square root of y squared minus the small radius 3 plus y squared, and then when we multiply it by dy, that gives us a little bit of thickness. So this is actually a piece of a cross section of the volume, and the integral sums them all up from 0 to 1 to gives us the exact volume. So let's simplify this. This is pi times the integral from 0 to 1 Expanding 3 plus square root of y squared gives us 9 plus 6 square root of y plus y. Then subtracting the expansion of 3 plus y squared, that's 9 plus 6y plus y squared. And so we can see that 9 minus 9 cancel. We have pi in front, the integral 0 to 1. 6 square root of y doesn't cancel with anything. Y minus 6y would be minus 5y, and then minus y squared. And then integrate this with respect to y. This is not that difficult at all. Very straightforward integral. We have pi. The integral of square root of y, which is the same as y to the 1/2, is y to the 3/2 times 2/3, so 6 times 2/3 times y to the 3/2. Integral of 5y is 5/2 y squared. The integral of y squared is 1/3 y cubed, and that's evaluated from 0 to 1. Notice we plug in 0, we get 0, so just plug in 1. 6 times 2/3 is going to be 4, so this is equal to pi times plugging 1 in there will be 4 minus 5/2 minus 1/3. So you can see the common denominator is going to be 6, so pi times 4 is 24 over 6. Then 5/2 would be 15 over 6, and minus 2 over 6. So 24 minus 15 is 9, minus 2 is 7. The final answer, 7 pi divided by 6. For more videos,